Hello everyone, this is Dr. Prashanth Kumar, working as Assistant Professor in CSE Department in Marri Laxman Reddy Institute of Technology and Management. Okay, let's get into the topic. So today, the agenda of today's topic is mainly we are going to discuss history of DBMS, real-time applications, and finally we are also going to discuss about ER diagrams. So these are the three topics we are going to discuss in this today's topic. Let's get into the topic. History of DBMS. So DBMS is a software. It is used to store or manage or retrieve the data from the database. In 1960s, Charles Bachman, who is the first person, has introduced the DBMS, and it is called as Integrated Data Store. After that, in 1970s, Mr. Edgar Cord, who proposed new data representation framework, which is called as relational database. So nowadays, in DBMS, what we are going to use is relational database, and it provides a way of representation of data in the form of tabular form. So whatever the data you are going to store in the database, it is going to have the collection of rows and columns. In that table, you are going to store the data. Right. Then what about the applications, real-time applications of DBMS? Majorly, we can see in banking sector, universities, online applications, airlines, railway reservation, bus reservation. So these are the real-time applications we are using nowadays. Right. Next topic is ER diagrams. What is mean by ER? ER is nothing but entity relationship diagram. An entity relationship diagram is a pictorial which is going to explain the relation between entities to be stored in the database. So by using ER diagram, you are going to represent in a pictorial format. For example, suppose if you want to construct a house, then what we are going to do? We are going to approach a civil engineering. What the civil engineering going to do? He is going to take the plan from us, and he is going to draw a blueprint of the house. So based on that blueprint, he is going to start the construction. Similarly, in database also, when you are going to store the data, or when you are going to create the data in database, to create the database, we are going to use the ER diagrams as a blueprint. So that by using this ER diagrams, you are going to represent how the data is stored in the database. In ER diagrams, it is a structural design of a database. Not only it is a structural design, and it acts as a framework created with specialized symbols for the purpose of defining relationship between the data entities. So relationship between data entities, you are going to create a framework. An ER diagram is created based on the three principles. One is components, one is entities, attributes, and relationship. So in any ER diagram, we have three components. One is entities and attributes and relationships. Right. So you can see in the diagram. So this is an ER diagram example. Here the entities are nothing but codes. So student. Okay. So these are called as entities, whereas attributes are course name, course ID, student age, student name, and student ID. So these are the attributes, and these are the relationship between these entities. So what is the relationship between this student and course? We have study. So student will take a course to study. So this is called as relationship. Next. So what are the symbols we are going to use to draw the ER diagrams is, one is ellipse. As we seen in the diagram, we have seen ellipse is represented for the entity, where diamond is used for the relationship, and we also seen the oval shape, which is represented as a attribute. Okay, and in this we also use primary key and double ellipse. So what is mean by primary key and double ellipse? Here it is underlined attribute. So for example, if you take a student table, in student table we will be having unique values. So unique values are for example like roll number. It is represented as a primary key. whereas double ellipse is used to represent the multi values. For example, if you take a student can contain multiple mobile numbers, like he may have two or more mobile numbers, mail IDs, okay, house address, there is a two or three house address. In such cases, you are going to represent by using multi values. So these are the ER diagrams, like entity, and next this is attribute, weak entity, derived entity, relation, and multi-value. We are going to discuss about these diagrams in detail next slide. Right. Next, components of ER diagrams. Based on ER diagram, we have three components already we discussed. One is entities, attributes, and relationship. In these three components, we have sub components, like in entity we have weak entity, in attributes we have key attribute, composite attribute, multi-value attribute, and derived attribute. When coming to the relations, we have one-to-one relation, one-to-many relation, many-to-one relation, and finally we have many-to-many relation. So in these three components, we have sub-components, and we are going to see each sub-component in detail. Right. So first one is entity. So what is meant by entity? An entity can be either a living or non-living component. So entity can be a living or non-living component. It shows an entity as a rectangle in a ER diagram. For example, so see here, we have student entity and course entity, where student is a living entity. When coming to the course, it is a non-living entity. So an entity can be a living or non-living. Okay. In this example, if you see that a student is registered for the course for the sake of study. So what is the relation between the student and course? That is study. He is going to register for the course because for the purpose of study. So in this way, you are going to represent a relation between two entities. Okay. So relation is used to connect the two entities. Next, in entity we have a weak entity. What is meant by weak entity? An entity that makes reliance over another entity is called as a weak entity. Okay. So it is going to make reliance over another entity. For example, if you see this diagram, here we have school, one entity, classroom, it is also one entity, and these are the school number and room number or the attributes for the particular entity. But see, in this example, school is called as strong entity because it has a primary key. Okay. So for every school, they will be having unique school ID when they are going to register. Okay. And unlike school, classroom is a weak entity because it does not have any primary key. So in class, we don't have any primary key for class, that is called as weak entity. When a entity having primary keys, then we'll call it as strong entity. When there is no primary key for the entity, then we'll call it as weak entity. In this example, school is the strong entity. Then coming to the classroom, it is a weak entity. So weak entity is nothing but which is not having any primary key in that. Okay, that is called as weak entity. Next one is entity set. So what is meant by entity set? In DBMS, an entity set is a group of entities that are similar type and have same properties. Okay, we'll take one example. If you take this car, for example, there is a Marri company. Okay, so it has different types of models like Shift or Wagoner. Okay, different types of models are present in that particular company. Now, suppose if I am going to take only about Shift, then it is a single entity, and I am going to take the attributes for that particular car for Shift, like car color, car steering, car seating. So what is the fiber we are using for seating? All these are the attributes for that particular entity. But in entity set, here we will be having same properties, but similar for different car model we will be having different what properties, same properties is called as entity set. For example, see here in first entity we have DL123, it is the registration for that, and model is what? LDI. What is the name of the car? Red, color white, and number of seats is 5. So this is single entity. But here we have two models, another extra models, that is registration number, VDI, shift, black color, and number of seats is 5. When the combination of entities is called as a entity set. If it is a single entity, we will not call it as entity set. When there is a combination of entities called as entity set. So this is the example for the entity set. Next component of ER diagram is attributes. An attribute exhibits the properties of an entity. So what is mean by properties of entity? For example, if you take a student, okay, so what are the properties we'll have for the student? Like student name, roll number, phone number, age, branch. Okay, similarly if you take an employee, for employee you'll be having employee ID, employee name, age, which project he is going to work. Okay, so property is nothing but if you take an entity, so what are the properties for that particular entities are there, we'll call it as attributes. Okay, for example, if you take this diagram, here we have a student. So for every student they will be having some properties like age, roll number, name, address. So these are the properties of a student. Similarly, you can also take the employee. Okay, so for employee you will be having employee ID, next employee name, employee address. Okay, so these are the attributes or properties of a employee. In this way, properties are represented as a attributes. Next is a key attribute. What is meant by a key attribute? Key attribute uniquely identify an entity from a given entity set. Okay, for example, if you say, see here we have a student. Okay, in student we have age, roll number, address, and name. See, we have 4 properties here. A student having age, name, address, and roll number here. Suppose if you take another student, a student can also have same age, which is having already for first student, and he can also have the same name. Okay, to avoid these duplications, to avoid this confusion, we'll take as a key attribute. Key attribute is used to identify uniquely for a given properties. So for every student will be having roll number 1 only once. Okay, here roll number is a key attribute for this student entity. These key attributes are represented by underline. Okay, see here in address, name, age, roll number is underline, means it is a key attribute. Key attribute is used to find out the unique values from a given entity set. Right. Next one is composite attribute. A composite attribute is used for several several other attributes are known as composite attribute. An attribute that is composed. So an attribute that is composed of several other attributes. Okay, so an attribute, single attribute is composed with the several other attributes is called as a composite attribute. For example, if you take here where we have a name attribute, for this name attribute we have first name in this, middle name, and last name. Means see here an attribute that is composed, already name is a attribute, it is composed with the several other attributes. Okay, like first name, middle name, and last name. Those type of attributes are called as composite attributes. Next, multi-value attribute. Some attributes that can possess over one value those attributes are called as multi-value attribute. See, possess over one value. Okay, so those type of attributes are called as multi-value attribute. For example, see, take same student, where student has roll number, age, name, and phone number. Okay, but a student can have two numbers. Okay, in such cases which possess one or more value, then we'll call it as multi-value attributes. Multi-value attributes. So this is about multi-value attributes. Derived attribute. So what is meant by derived attribute? An attribute that can derive from other attribute of the entity is known as derived attribute. Okay, so what it is saying, it is derived from the another attribute. So already we have attributes. From one attribute you are going to derive the another attributes are called as derived attribute. In this example, student, where we have date of birth, okay, address and name. Suppose I need the age of the student, then what you are going to do, by calculating the date of birth, by taking the date of birth from starting to present year, we can find out the age. So this is called as the derived attribute. So from one attribute you are going to derive the age. From date of birth you are going to derive the age. These types of attributes are called as derived attributes. Next, relationship. So we have seen two components, that is entities and attributes, and the next component in the ER diagram is relationship. So a diamond shape showcase a relation in the ER diagram. So what is meant by relationship, and it is represented by the diagram. When you want to represent the relation between two entities, then we are going to use the relationship. See, in this diagram we have student, one entity, and we also have course, it is one entity. Now for these two entities we are going to establish a relationship, that is called as relationship, that is study. So this is the relation between student and course. Study is the relation between student and course, right? In relationship we have four types of relation: one to many, one to one, many to many, many to many, many to one. So first we are going to discuss about one to one relationship. So what is meant by one to one relationship? When a single element of entity is associated with the single element of another entity. It is clear that when a single entity is associated with another single entity is called as one to one relationship. For example, if you take the student, okay, for student will be having identity card. So student is an entity, identity card is one entity. For every student will be having a single identity card. Okay, so that is ID card. Then what is the relation between these two entities? Student has, so this is relation. Student has ID card, means a student is single and ID card is single. These types of relations is called as one to one relationship. One to many relationship. When a single element of an entity is associated, single entity is associated with more than one element of another entity is called as one to many relationship. So a single entity, it is having another entity which is having many. For example, if you see the customer, so customer is only single, but orders are many. So suppose if you log into the Amazon, okay, so in Amazon a customer can place multiple orders, okay, means customer is single, one, whereas orders are many. Such type of situations are called as one to many relationships. Next one is many to many, many to one relationship. When more than one element of an entity is related to a single element of another entity, then it is called as one to one, many to one relationship. If you take student, he is a single student where another entity is course, where student is enrolled for different courses. For example, if you take in course we have Java, C++, sorry, and Python. Okay, a student can enroll multiple courses. In these situations, where student is one entity and courses are multiple, then we'll call it as one many to one relationship. Next one is many to many relationship. When more than one element of an entity is associated with more than one element of another entity. So if you take an example, here we have one entity that is employee and another entity as a project. Okay, in employee we have many employees. In a company, if you take any TCS or any Amazon, where we'll be having multiple employees. Similarly, for multiple employees will be having multiple projects. So group of employees will deal with some other project, another group of employees are deal with another project. Then this type of relationship is called as many to many relationship. See here, employee is assigned with different project. So group of employees is assigned with the group of projects. So this is called as many to many relationship. Right. Next one is relationship sets. A relationship set is a collection of relationships that are all of same type. Okay. Suppose in previous example, here only we have single relationship where we have two entities and it is represented by one relationship. But here, if you take here, see Anil, these are the two tables where we have roll number and name in one table and course ID and course time in the other table. Now Anil is registered for the course ID 202, that is Python, whereas Rahul registered for the course ID, that is 201, Java, and Vamshi is registered for the course ID 203, that is Hypernet. So relationship set is a collection of relations. So these are the different relations. Then it is called as relationship set. Next, degree of relationship set. The number of entity sets that participated in relation set is termed as a degree of relationship set. So what they are saying that participating a relationship, entity sets are participating in a relationship set is termed as a degree of relationship set. For example, if you take here, degree of relationship set is equal to number of sets participating in relationship set. Okay. Here we have types of relationship set. One is unary, binary, and ternary. Okay. So we have three types of relationship set. Excuse me. First one, unary relationship set. A unary relationship set is a relationship where only one entity set participate in a relationship set. Okay. Suppose if you take this diagram, here we have one employee. Okay. So is a single which is having relation manage the employees. So manager manage the employees. Here we have only single relationship between this entity and relation. Then it is called as unary relationship set. Coming to the binary relationship set, binary relationship set is a relationship set where two entities participate in a single relationship set. For example, students, courses. Okay, here we have student one entity and course one entity. Here multiple relationships are used between these two entities, that is student enrolled in the courses. This type of relationship set is called as binary relationship set. Last one, ternary relationship set. Ternary relationship set where three entities participated in a single relation. Okay. See, if you take doctor, medicine, and patient, these are the three entities we have. These three entities is combined relation between them by using prescribes. This type of example is called as ternary relationship set because patient, doctor, medicines is is used relation to connect these three entities. Sorry. Additional features of ER diagram. As the complexity of data increased, it became more and more difficult to use traditional ER model for database modeling. Okay, in such cases, they have introduced additional features in the ER diagram. Sorry, that is generalization, specialization, aggregation. So these are the three additional features which are used in ER diagrams. Okay, so we'll see one by one. First one is generalization. Generalization is a process of extracting common properties from a set of entities that are creating a generalized entity form. And it is a bottom-up approach. It helps to reduce the size and complexity of the schema. Okay, for example, if you see this diagram, here we have two entities. Okay, contract employee, hourly based employee, and these are the attributes for these entities. Now what I'm going to do in generalization, I'm making these two entities into a single entity set, that is employee. Okay, so we have two entities, that is contract employee and hourly employee, and there are common properties, that is nothing but common attributes between these two entities. Instead of writing separately, I'm generalizing these two entities into a single entity, that is employee. So this is the process of generalization. Next, specialization. Specialization is the opposite to the generalization. In this, entity is divided into sub entities. So it is reverse to the generalization. In generalization, what we are going to do? Suppose if you have multiple entities, we are going to convert into a single entity. Whereas in specialization, here we have single entity. We are making that single entity into separate entities. Like if you take this employee, okay, in this employee making again hourly employee separately and contract employee separately. Then this process is called as specialization. So specialization is the reverse order of the generalization. Next, aggregation. The specific entities are combined because they do not make sense on their own. To avoid that, aggregation refers to process by which entities are combined to form a single meaningful entity. Okay. So if you see these diagrams, we have supplier, product, and customer. Customer will buy the product, whereas supplier is also buys the product. Okay. So in this diagram, instead of writing supplier and product separate entities, we are combining those entity into a single entity. See, supplier, product, we make it as a single entity. Instead of creating separate two entities, we have created as a single entity. Now customer buys along with the supplier what? Products. So writing different entities separately, we are going to combine the two entities into a single entity is called as aggregation. So this is the example. We can see that where we have supplier, customer, and product, we are making supplier and product as a single entity, and customer is another entity, and we are going to create the relationship between these two entities. Where previously we have three entities here, but in this we have created into two entities. This is called as aggregation. Thank you. I wish you understand.